Hello everyone. So today's live broadcast is on the topics of hypothesis testing and design of experiments. And Mr. Hindol Basu from Tata Industries will be walking us through the industry applications of testing and design of experiments. The questions, if you have any questions regarding the topic, you can put it in the chat, and the chat moderator will aggregate all of those, and we will be accumulating all of them, and in half an hour, in a interval of half an hour, we'll be asking Mr. Hindol your questions. So I'll pass over Miss pass over this to Mr. Hindol. Mr. Hindol, you can take it from here.
Hi, good morning, everyone. Hope all of you are able to hear me properly. So what we are going to do is today we will talk about hypothesis testing and a few real-world applications of hypothesis testing. And as Saif mentioned, do not hesitate to ask your questions, note them down, and every half an hour or so, Saif will collate all the questions and we will have a quick question answer session. Okay. So I'll go to a presentation. I have a short presentation which I will be using. Just let me open the presentation to show it to you. Okay. Saif, you are able to see my screen? Hello?
Oh, yes, I can see you.
Okay, okay, great. Great. So, as always, the objective of the session is to elicit a few thoughts in your mind and not to quote-unquote teach you per se. So I'll raise a few questions, provide you a few perspectives, and have a discussion with you about some of the questions that you have. The objective of this session is to give a real-world application flavor to what you have already been studying as part of your course modules. So that way, the objective of the session is not to teach you anything new, but to put whatever you have understood and whatever you have been taught in the context of real-world problems and application that you will face day in and day out when you complete your course and you are ready to apply some of the concepts in the industry. Okay, so that's kind of the premise of this discussion. It's not to teach you anything new per se. So this is how we will have the agenda laid out for today. First, we will have something that I call is a landscape of hypothesis testing. So there are quite a few tests that you must have learned about, and each one of them are used in a different context. So I will like to lay out the types of hypothesis testing that we usually encounter in real world. However, I'll not go into the details, statistical formulation of each one of them, because that itself will take a couple of days for me to cover. I will leave you with the slides, and if you do not know the statistical formulation of some of these tests, I would encourage you to go to the internet, find out, talk to the professors, or even we can have a separate discussion just on the statistical part of hypothesis testing. Okay. So after we cover that, we will have a few real-world problems on hypothesis testing. Some problems that you will find out day in and day out as you go into the real world and start leveraging analytics. These are some of the real-world problems on hypothesis testing. Then we will talk a little bit on test versus control in a little bit more detail. The reason is because test versus control studies or test versus control analysis is possibly the area where hypothesis testing is used.
I need to interrupt you. Your screen isn't visible currently.
The screen isn't visible?
Yeah.
Let me. Oh, I see. I see. Give me a moment, please. Okay. Share screen, share once more. Let me know if it gets visible now.
Yeah, it's visible now.
Okay, great, great. Sorry everyone for that. So this was the landscape that I was, or the agenda that I was talking about. First, we will go to the landscape of hypothesis testing, where I will tell you about the number of different tests, but I will not go into the statistical details of each. I would encourage you to find out over the internet or talk to your professors. If you are interested, we can have a separate session just on the statistical part of hypothesis testing, along with the mathematical formulation, proofs, etc. As I said, we will cover test and control in a little bit more detail, because test and control is something in real world where we have the maximum application of hypothesis testing. Then we will go into testing of distributions. So if you are given a distribution, how do you know? Does it look like a normal distribution? Does it look like a Poisson distribution? How do you test that? And some real world applications of that. Then we will go into type 1 and type 2 errors and cost of errors. Again, I will not go into the details of how to perform a hypothesis test with a 99%, 95% confidence interval. But what I'm trying to explain to you is, how do you use real world numbers to arrive at the confidence with which you should test a particular hypothesis. And at last, we will have a short sort of a case study on design of experiment, where I will talk about what design of experiment is, and how to look at design of experiments, how to analyze design of experiment results, and we will talk about design of experiments with interaction effect and without interaction effects. Okay, so that's what is the agenda for today. So I'll go on to the first topic, which is the landscape of hypothesis testing. Okay, so what do we test? So usually, as you must have already learned, we have two types of data: quantitative data and qualitative data. First, we will talk about how do we test hypothesis, or what do we test in the world of quantitative data. This slide is a busy slide. It has a lot of information on it. So what I will do is I will go through this slide in brief, but I will send this slide to you. If there are certain tests within these slides which you do not know, I would request you to find out. So first of all, as you know, whenever you look at any quantitative data, we usually look at mean, we look at standard deviation or variance, we look at mode, we look at skewness, we look at kurtosis. That's how we summarize data. Okay, these are also called your moments. For example, mean is your first moment, variance is your second moment, skewness, kurtosis are third and fourth moments. Now, if you have to test variance, how do you test variance? For example, if you have two sets of data, say income of people who have completed science versus income of people who have completed their studies in literature. You want to test what is the variance of their income, not the mean. You want to test the variance. How do you test the variance? So to test the variance, first we test the normality of the data. Is the data normal or not? Which is in the left side of the slide. And the test that we use for testing of normality is a test called Anderson-Darling test, which is a pretty common test for testing normality. So if you find that the data is normal and there are two samples, then we use something called Bartle's test for testing if the variance are equal or not. For non-normal data, for single sample, we use a test called Levin's test. And for multiple samples, we use the F test. I'm not sure if you know about all these tests, but at least you must have read about F test. What F test does is you have two samples with two different variances. You want to know if the variances are same or not. You use something called the F test. Okay. If time permits, we can look at a few of these in Excel today at the end of the session. Now, when you try to test means, again, you have to test whether the distribution is normal or not. And that you test again by using a Anderson-Darling test. Now, some cases, the distribution may not be normal, but you can leverage the central limit theorem. So what does the central limit theorem says? It says that irrespective of the base distribution, if you create various samples out of that distribution, those samples should follow a normal distribution. So for this given sample, if you have got a certain mean and a certain standard deviation, you can say that all these samples would follow a normal distribution with mean as this mean and the standard deviation as the standard deviation of this divided by root n, where n is the number of samples that you have used. So by using the central limit theorem, you can still use the normality assumption for testing mean in quite a few cases. Again, you may have one sample where, say, for example, you have the distribution of people who have income of people who have studied at analytics at upGrad, and you want to know if their income is above 10 lakh rupees. So that is where you use a single sample t-test. Now, say there are students who have completed digital marketing at upGrad and who have completed analytics at upGrad, and you want to know if the salaries of students who have completed digital marketing is higher than the salaries of students who have completed analytics. There is what you have two samples. And for two samples, there are few tests which we use for finding out if the salaries of students, average salaries of students completing digital marketing and analytics are same. Oh. Now, here is one concept that I would like you to keep in mind, which you may or may not have covered in your theoretical course, theoretical discussions, which is the concept of paired and non-paired samples. Now, this is a slight bit of a fine difference, and you should note it this way. Now, say you want to find out whether the salaries of students who have completed digital marketing and who have completed analytics are different or not. That is a two sample. Now, you may also want to know what is the impact of upGrad program. So therefore, you are looking at pairs. For example, you are looking at students who have done a course and you are comparing their salaries before and after. So it's the same student, salary before taking the course or after taking the course. And this comparison you can do for digital marketing and you can do for analytics. That is what is called a paired sample. So there's a paired sample and non-paired sample. We will go into it a little bit more detail when we talk about test and control, but this is just what is the difference between paired and non-paired. Okay. The other test which you encounter very often is a test called ANOVA. What ANOVA does is, till now we have always been talking about two samples. Now, so that's a limiting factor. In real world, you will always not have two samples. You may have 10 samples. You may want to know if the salaries of students completing digital marketing, analytics, another course A, B, C, D, they are all equal or are they different? So whenever you have multiple samples, you use ANOVA. Now, you may again say that I have multiple samples, but I know that students with more experience tend to get more salary. So I need to control for the factor, because digital marketing may have more experienced students who have registered for the program compared to analytics. So how do you take care of that? So that is a test that we use, is called ANCOVA, or analysis of covariance as well. So you also control for the contributing factors. So the idea of this slide was just to give you an overview or the lay of the land for the types of testing that are used. As I said, I'll not go into the detailed mathematics of any of them. I encourage you to go through this slide and find out some of this from the internet. Okay? I'll go to the next slide. Now, we have looked at testing of means. Now, we can also test medians, right? Now, as you know, in case of a well-behaved distribution, like a normal distribution, the mean and median are the same. So you can as well use the same test for mean and median in case of those kind of distribution. For other distribution, there are different tests that we use to test the median. Again, if you are using a one sample, for example, the same example, if you want to know if the salaries of students completing analytics course is more than 15 lakhs, if the median salary, which is a pretty common example for calculating salaries, is if the median salary is higher, then you use a one sample test. If you, on the other hand, if there are two samples, for example, if you are asking, is the median salaries of students completing digital marketing higher than the median salaries of students completing analytics, then there are a few tests which, for example, are the most common is the test called Mann-Whitney test, which is again a non-parametric test. It doesn't have any distributional assumption. In fact, most of the tests for median are non-parametric tests. And I have listed out the tests, and I would request you to go again and figure out some of these tests in detail. Okay? So with this, I will go to the next slide, and I will talk about a few real-world examples. And these are examples that you will find in any job or any analytical job that one takes up. So first is the most common, which is called a test versus control. And it usually comes in this way. Say, for example, you are a shopper stop. You lead the analytics for shopper stop. And you know shopper stop has a loyalty program, which means for a certain number of their customers, they have this loyalty card and a loyalty number, and they know those customers exactly. They know the email ID and phone numbers of that customer. And whenever that customer comes and shops, shopper stop has information about what the customer has shopped, in which store, etc., everything that you can think of. Now, as you must have seen in real world, during festive seasons, that is during Diwali, Christmas, etc., you tend to get a lot of offers. So if you are a shopper stop loyalty member, you will get offers from shopper stop saying that there's a 5% discount, 10% discount, etc. And you as an analytics head for shopper stop, you see that after that the festival season is off, you have seen a big surge in your sale. Now, the marketing manager will come and ask, why did we see the surge? Did we see the surge because it was Diwali? Or did we see the surge because it was the 5% off? Or was it because it was Diwali and it was 5% off? So how do we answer this question? A very, very common use of hypothesis testing. We will talk about it as a test and control. So what you need to do is you need to keep aside a control group and figure out the impact of the 5% price off on the control and see if the impact is significantly different from what you see in test. And that only can give you a conclusive answer if this 5% price discount really makes an impact on your sales. Okay. Now another few examples. Now think of, so we will go about in detail about this. Now, in this first case that I just described, what you can do is you can create or you can set aside a control group. What that means is you can set aside, maybe say you have 10 lakh customer. You can separate out some 50,000 customers who will not get the price discount offer in their email or SMS, etc. Now, and then you can compare the test versus control after the festive season, because the festive season is same for both the test and control. Both of them experience Diwali. The test group experiences the 5% off as well. The control group doesn't experience that. You can really measure the impact of that 5% off using a hypothesis testing framework. Now, there are many other cases where you can't really create a control group of this type. Let me give you an example, which is the first example in the slide. Say you are HSBC and you have a credit card, and you have tied up with a few restaurants in your city. And on the restaurant tables and everywhere in the restaurants, you have put sign posts and advertisements saying that if you use your HSBC card, you will get 10% off, right? And some customers go to the restaurant, see that offer, and takes out his or her HSBC card. Now the question is, how do you take a control group for this? Because you don't know who is going to go to the restaurant. You can't really tell some people that please don't go to the restaurant. Or once a person goes to the restaurant, that everyone will see the promotion, or everyone will see the advertisement on the table of the restaurant. You can't take out that advertisement for certain people. That's just not possible. Then in this case, how do you understand what is the impact of the price of? So here in this case, you have to create a control group, and we'll talk about how. Similarly, think about another case. Say again, let's take Shopper Stop. So say you have walked into Shopper Stop and there is a huge cutout of a movie celebrity wearing beautiful clothes, and based on that, you see there is an increase in sale. Now, how do you know if putting this movie celebrity's photograph makes a difference? Because you can't really blindfold certain people and tell them not to see that picture. So therefore, what you have to do is you have to identify another store which is exactly like this particular store where you have put the movie celebrity's photograph, and see that if you do not put the photograph in the other like store, what happens to sale? Okay. So here again, how do you identify a like store? So say you have a store in Bandra in Mumbai, and you have put Shah Rukh Khan's photograph there. You have to find out another store which exactly looks like the Bandra store, where you will not put Shah Rukh Khan's photograph. Now, how do you identify that? Again, we have to use hypothesis testing. In fact, we use ANOVA and ANCOVA quite extensively for this kind of problems. Some other uses of hypothesis testing. One is sampling. As you know, in many cases, we conduct sample surveys. So you want to go to your customers and ask them about their preferences, about what they like, what they don't like, etc. So now the biggest question that we have while designing a survey is, how many people do I survey? Is 100 enough? Is 1,000 enough? I don't know. So again, concepts on hypothesis testing are important to find out. How do we select a number of people which is significant enough for me to have meaningful insights out of a survey? Another very related area on survey. Say you have selected a sample for conducting a survey, but it's a sample. How do you know that this sample is really quote-unquote representative of your population? Again, what you have to do is something like hypothesis testing. Okay, so these are some of the real-world examples on hypothesis testing. We will go into detail about test and control and usage of hypothesis testing for test and control, and I will use that example to talk about how to use hypothesis testing in real world. Okay. Now, this is what is test versus control. Now, what it means is, now let's again go back to that example. Okay. So that same Shopper Stop example. So you have, so say Shopper Stop has 10 lakh customers, and it's Diwali time, and you want to send a promotional offer to these customers saying that in Diwali, if you shop at Shopper Stop, you will get 10% off. Okay. So what do we usually do is we first take my 10,000, my 10 lakh customer and create a sample out of it, which we call is a control group, which will not receive the 10% offer. Now, there are two philosophies of keeping the control. What you can do is, just prior to Diwali, prior to this offer goes out, you can select a sample of customers who will not get the offer. This is a control group which is just for this particular treatment, which is designed to understand the impact of only this treatment. However, some of the more analytically advanced companies in the world, they use a concept called universal control. What they do is, say every month in Shoppers Stop, 10,000 people enroll into the loyalty program. Out of 10,000, I always keep out 10% of people who do not receive any offer from Shoppers Stop at all. And that is what we call as a universal control group. And every offer that is made by Shoppers Stop is compared against this universal control group. So that's a concept of a universal control group. But not many companies are still today in India at least sophisticated enough to have a universal control group. However, at least for each particular offer, most companies do use or do keep aside a control group. Now, then the next question is, say you have 10 lakh customer and you want to take out 10,000 of them as a control group for this Diwali price of or discount offer. Now the question is, how do you select this 10,000? Easy answer is, we take randomly, I take 10,000. But when I take randomly 10,000, I have to ensure that this 10,000 is really representative of the full population. So we test the hypothesis in the pre-period, or that is before the offer, before Diwali. This 10,000 exactly behaves like the full population. Now, what do you mean by exactly behaves like the full population? That means their average monthly sales is same as the full population. If you take a historic period of 12 months, in every month, the average sale of this control group is same as the average sale of the other group, which is the test group. Even the growth in their average sale is same as the test group. So that I am 100% certain that this control group is exactly like the test. Okay? Once you have ascertained that, then you have statistically proved that your test and control are identical in the pre-period. That means the control group is a true control group. And whatever learning you find out in the post-period, then can be attributed to the treatment, which in this case is the price discount. Now, then how do you find out if the test is performing better or there is more sale happening in the test group compared to control? So you test the hypothesis that in the post period, that is after the campaign. So say this is Diwali is in November, and from 1st of October, you send this campaign to everyone in test. You do not send the campaign to everyone in control. And come 1st of December is your post period, when the Diwali purchase has already happened. Then in the post period, you test the hypothesis if test minus control is greater than 0. Or you test the null hypothesis that average sale in test is equal to average sale in control. And if you are able to reject that null hypothesis, then it means that this difference in sale is attributed or can be attributed to the price discount, because otherwise the test and control are still same. Now, here again, please refer back to what I said about the paired sample t-test. Now, what a paired sample means is, now everyone in the test and the control also has experienced Diwali, because as you know, there is an impact of the price discount, but there is also an impact of Diwali. Everyone shops more in Diwali. So the post test, or that is during Diwali, minus pre-test, that is before Diwali, this difference for test group and this difference for control group, there is a difference. So control group also sales go up during Diwali because anyone shops more in Diwali. That's known. But the question is the pre minus post difference more in test compared to control? So that is where we can also do a paired t-test, test pre to test post, control pre to control post, to find out what is the impact of Diwali. Because there are two things happening together. There is this Diwali and there is this price discount. You want to know what is the impact of Diwali, you want to know what is the impact of pricing, and you want to separate them out. So if you perform a paired t-test between pre and post for control, you can find out what is the impact of Diwali. And then you want to know what is the impact of price. And then essentially for test, you are having both these impacts together. Impact of price plus impact of Diwali. Okay. So what I'm going to do is I'll have a quick pause here, and would like to ask you if you have any questions before I go into some of the other real world case studies on hypothesis testing. Hi Saif, are there any questions?
No, there doesn't seem to be any questions right now.
Okay, fair enough.
So you can continue for now.
Fair enough. Okay. So, so having looked at the test versus control example, let's look at the few other problems that I spoke about. Okay. So I will take this problem. So in this sampling, we have a problem. For example, I want to design a survey, and I want to know what should be the size of my survey. Okay. What I'll do is I'll kind of solve this in Excel with you, so that you have a feel about hypothesis testing as well. Okay. Allow me to go to Excel for 1 minute. Okay, are all of you able to see my Excel sheet on my screen? I hope so. Okay, now let's assume that I am going to conduct a survey. And in the survey, I want to ask yes, no type of questions, like do you like my product or do you don't like my product? Will you buy another product from me in the next 3 months, or will you not buy? So these are the most difficult questions in survey from a hypothesis testing perspective, because you tend to get sometimes almost a 50-50 answer. So say 49% people say that they will buy and 51% say that they will not buy. So how do you make a conclusion? So let's say I have a question of this sort, which is a yes no question. Okay. And let's say I have my sample size. Okay. So the sample size, say it goes to a minimum of 100. And then I increase my sample size by about 10 in each case. So let's take a few examples. Okay, so I have up to about 2000 sample size. I know I can't go beyond about 2,500 sample. Draw it once more. 2,000. Okay, so my sample size can go up to 2,500. Now, let's say there are questions where the respondents answer almost at the border. Say you get a 51% people saying yes. Okay. So now, if a 51% people say yes, what is the mean of your distribution? So it's a binomial distribution, right? So people say either yes or no. And we know when you have larger numbers, the binomial kind of tends to a normal. So say the mean is 51, 0.51 in each case. Now, if you have a mean of 0.51 for a binomial distribution, what is the standard deviation when a binomial tends to normal? So hope you will remember it is p, which is the mean, multiplied by 1 minus p, okay, divided by n, which is the number of the sample, and square root of the whole thing. Okay, so I'll calculate this way. This is p into 1 minus p square root of the divided by n, which is the sample size, and square root of the whole thing. Okay. And as you know, when we want to study, when we want to reject our null hypothesis, we usually go into a plus minus 2 standard deviation range. Okay. So my range is from 2 sigma, 2 multiplied by sigma. So that is on the plus side. So mean, so I have to add the mean as well, plus 2 standard deviation. So I will say upper range, and there's a lower range, which is mean minus 2 standard deviation. Okay, fine. Now let us plot the lower range and upper range. Okay, so I will take these two and plot them. Okay, I'll make this axis a little smaller so that you're able to see what I want you to see. Okay, now can you see something interesting? As you increase the sample size, the range is sort of becoming smaller and smaller, and it's almost become a parallel line. So the point beyond which, I'll make it larger so that you can see. So the point from which it almost becomes a parallel line is about, I would say, 200, 218 kind of sample. So you can say that in this kind of a scenario, I need to take at least 200 or 218 sample. Because if you take 50, a sample of 50, and a sample of, say, 100, there is a big difference in the range. Your range really goes down. Therefore, you can use a very simple hypothesis testing here that I did with you to see what should be the number of samples that you should use for conducting a survey. Okay? Fine. We will get into another quick example. Okay? Another quick example of hypothesis testing in a test versus control scenario. Okay. Now, remember the example that we showed in the presentation with the test control, pre-period, post-period, all of that. Okay. So let's say I am using 12 months of pre-period and then the Diwali offer in the next 1 month to find out the impact of test versus control. Okay. Now, this is say M1, which is month 1. This is month 2, etc., etc. I'll take up to 12 months. This is 1 year. And the reason we take 1 year in the pre-period, so this is my pre-period. I'll do this entire example with you so that it's possible for you to get a feel of hypothesis testing in real world. So the reason, it would have been good if it would have been an interactive class. I would have asked you, why do we take 12 months in the pre-period? We take 12 months in the pre-period because something like in an example of shopper stop, when you are shopping for clothes, there is a cyclicality. There's a seasonality in your purchase. We invariably tend to purchase more in certain seasons. Therefore, it is important that we take a 12-month pre-period to ensure that the test and control are really similar. Because if we take only a 3-month or a 6-month pre-period, the test and control may look similar in the 3 months, but they may not have looked similar during the festive season. And this also brings out the reason why it is better to have an universal control group. Now think of it. Now this is say Diwali month here. Okay. Now here M1 was Diwali again, right? Now there may be someone in your control group who was in the control group in last Diwali, and someone in the control group who was in the test group in last Diwali, and similarly in the test group. So it will kind of get very what should I say, hodgepodge in the way the test and control gets designed. Therefore, making a universal control group is the most analytically sound strategy to adopt when measuring test versus control. Okay. Now, say if you have a test and the test, sorry, something happened. What happened? Okay. Saif, is my screen still visible?
Yes, it is.
Okay.
Okay, so I'll just ask a question. There's a question with respect to a control and test group. Since you're speaking about it, so I thought about asking it. So a student has asked that how do we define a control group? Like, is it the one that receives the discount, alerts, etc., and the test group does not receive? So they need some clarification with respect to control and test group.
Okay. Thank you. Thanks for the question. It's actually the other way around. What we say is a control group is where we control for the factor. That is, we do not communicate the offer to the control group. We communicate the offer only to the test group. Okay. So if you were saying that there is a 10% off offer, the offer is sent to the test group. It is not sent to the control group. Okay. Now the question is, how do you design the control group? To design the control group, what I said earlier, the control group should be exactly similar to the test group. For example, let's say you can't have that the control group has more young population compared to the test group. That's not right, because maybe young people shop more during Diwali. The most important thing to ensure in a test control measurement is that before your treatment or before your offer, the test and the control are identical in every single way that you can think about. Therefore, what I was talking about, how do you create the control? In order to create the control, before you administer the test or the offer, you select a random sample from your population. and you test that random sample. Say you have 10. Let me be a little even more detailed in it. Say you have total of 10 lakhs customer, and you want to select 50,000 as your control. Okay, and you have 9.5 lakhs that you said take as your test. Before you send the offer, you have to ensure that this 50,000 is exactly identical to the rest of the 9.5 lakhs on multiple dimensions. Some of these dimensions are transaction dimension. For example, the number of this number of sales, the total value of sales in the last 12 months, last 3 months, etc. And they should also be identical in their demographics and psychographic parameters. Now, you may argue that if you have taken a random sample, it should anyway be identical. That is, in the truest sense, right. However, you need to test it using, again, hypothesis testing, where you say that average 12-month sale is same in the test versus control. Each monthly sale over the last 12 months is same. Growth in sale is same. If all of this is identical, that means you cannot reject the null hypothesis. The null hypothesis is in the pre-period test is equal to control. You can't reject the null hypothesis. Only then you can say that the test is identical to control. Therefore, after the treatment, if I measure the difference between the test and control, the difference can be attributed only to the treatment, which is the offer in this case. Therefore, an universal control helps because a person who is in control today may have been in a test group 3 months back, 12 months back, etc. And that changes the dynamics. Okay. Hope you have your question has been answered.
Hindul, there's one more question.
Yeah, please.
So the student is asking how different is a control group from a universal control group?
Okay. Okay. Just a minute. So the way in which a control group varies from an universal control group is, in this case that I was just mentioning, you create a control group only for a particular purpose. Say you are going to have a Diwali offer, you create a control group for a Diwali offer. After 3 months, you have a Christmas offer. You create another group for a Christmas offer. In the same way. Now, the person who is in the control group for the Christmas offer may be in the test group for the Diwali offer, or may not be. You do not know that. What an universal control group is that you keep a set of customers aside from every single treatment or every single offer that you are going to run. That means you take out 50,000 customers at the beginning of the year and say that these 50,000 customers are not going to get any offer from me, be it Diwali offer, Christmas offer, Valentine's Day offer, Friendship Day offer, whatever offer it is. That is an universal control group. And in truest sense, what an universal control group means is, say you are doing all these offers, you are sending a birthday mailers, you are sending anniversary mailers to customers. All of this, you expect them to have a positive impact on the customer. The universal control group says that, does any of this matter? Or if you don't do any of this also, you will get the same sale from the customer. That's the idea of an universal control group. And the way the universal control group is kept is, every month you get new customers who enroll into your credit card, into your loyalty program, into your telecom program as a new mobile phone customer, whatever it is. Every month new customers enroll. And you take a small percentage of that, 5% or 10% of that, and say that this 1,000 out of this 1,000 customers who have enrolled today, I take out this 10 customers and they become my control group. I'm not going to touch them in any way in future. That's the concept of an universal control group. Okay. Any other questions?
No, you can continue. So we're all good.
Okay.
Thank you.
Okay, thank you. Okay. So now, if you see what I have done here is, there is 12 month, which is the pre-period. Then there is Diwali. And then there is post-period, which is after Diwali. Now, what we can have is, we can have the mean and standard deviation of the customers who are in the test group and the customers who are in the control group in the pre-period and in the post-period. You can also have, so this is the mean and standard deviation of sale. This is the sale. Okay. Now, similar to this, you can do it on various other factors. For example, you can have your rupee sales in rupee. You can have sales in number or number of transactions. You can have a growth in sales. So you can have a month-on-month growth in sale, how that person's sale is increasing. So obviously you will have one less month here because you are calculating a month-on-month sale. So fine. And obviously in month-on-month sale, there is no post period. So what you try to ensure is that the test is same as control in this entire pre-period before Diwali happens. So say if your mean sells, I'll just put some, I have some random numbers, I'll put some random numbers. And so on. And then you can have a standard deviation of 20, 30, 40. And you also need the number of people you have in the test group. Say in the test group you have, so your test is total of, the test is about say 5 lakh people. And your control is about say 50,000 people. Okay. And say in the control, the mean is 2,400, 2,500, 2,300, and the standard deviation is 30, it's 50, it's 20. Okay. So now in each one of the month, you are testing the null hypothesis as min test is equal to min control. Okay. Now what you do for this is, so if you have to test this hypothesis, you first need the difference of the mean. I'll just shift it here so that I can write all the calculations here. Okay. So difference in mean is mean test minus mean control. Okay. Then you have to calculate what we call is the standard deviation. Now, in the map that I had showed you, I'll just go back to the presentation for 1 minute. Okay. Are you able to see my presentation? Maybe not, right?
No, your presentation isn't visible.
Yeah, because that is not shared as well. So let me share the presentation now. Okay, is the presentation visible now?
Yeah, yes, it is visible.
Okay. Now, what are we testing here? We are testing mean, right? Which is in the right-hand side. Now, are we testing single sample? No, we have 2 samples, test and control. Okay. So, for this, we have to first test equality of variance. So, as you saw, there is a standard deviation of variance or the variance of the test and control population. Before finding out what test, so should you create a pooled standard deviation? How do you calculate the standard deviation for the test? You have to test whether their variances are equal or not. So you have to go through the slide before. you have to come here and you have to conduct an F test. If you look at the left hand portion of the slide, there is test of variance. You first test whether the distributions are normal, and then with an F test you test if the variance between test and control is same as well. That's the right way of testing an hypothesis. So you have to conduct an F test first to see if the variances are same, and then if the variances are same, then you have to calculate the standard deviation for this accordingly. Okay. Now I will go back to my Excel sheet. Share Excel share. Okay. So as of now, we assume that the variances are same. So we have to create something called the pooled standard deviation. Okay. So the pooled standard deviation, the way, and you must have studied it in your theoretical class, how to calculate it. Okay. So it is sigma square, I calculate variance, into the number of people in the test plus bracket around all of this, sigma square of control multiply the number of people in control. Okay. Then divided by the total number that I have of test plus control, test control plus test, and take a square root of the whole thing. Oh, there's something wrong in it. Just a second, let me calculate. Sorry, just give me a minute, please. This plus. Okay, in Excel you have to be careful with brackets. Okay, so now okay, so this is now the pooled standard deviation. Okay, now you want to know how far, how many standard deviations away from mean is this difference. So you have to calculate the significance. How do you calculate the significance? You go to a t-test. Now I'll go to a t-test here. In fact, you can use a z-test also because the numbers are all greater than large numbers, so it doesn't really matter. So now the question is, so should we do a one-tailed t-test or should we do a two-tailed t-test? Now here, ideally, where you want to just test equality, your null hypothesis is mean test is equal to mean control. Then we usually do a two-tailed t-test because your mean of control can be higher or can be lower. Neither of that is desirable. But in case when you go to the post period, you want the mean of test to be higher than the mean of control, then you conduct a one-tailed t-test. Okay. Okay, now my x is now my x becomes okay, test minus control, so this becomes this divided by 21. My degrees of freedom are more. They are, say, I will take 50,000 at least, doesn't really matter. So if you see, this is really, really low. So what we say is, yes, test is equal to control in this case. Okay. So you need to perform this test versus control, this significance for all the 12 months prior in the pre-period. Similarly, you have to conduct the same test for number of transactions and even growth in sales. Now, if for every aspect your test and control comes out to be same, then you can with certainty say that this test and control are really identical in the pre-period, and therefore what I will learn in the post period can be attributed only to the treatment. Okay, any questions up to here?
So there's one question with respect to the number of samples in the test and control group. So is it necessary for them to be the same, or is there a reason why we keep them different?
You have to keep them different because practically speaking, if you want not to give an offer to 50% of your customers, then the offer doesn't make sense. So if you really think that, say, you are Shopper Stop and you want to give your offer, and Lifestyle is give a lot of offers, so you can't say that to half of my customers I will not give any offer. Business is never going to allow you to do that. So always the test is much larger than the control. The control group is always smaller, but it has to be statistically significant. It doesn't have to be same, and by design it is always smaller, because in this example, as you saw, you have 5 lakh in test, 50,000 in control. Usually that is the case. You may have even smaller in control, but this hypothesis still needs to be satisfied. Now, as you have asked this question, what I will also do is, I hope you are still able to see my screen. I will make the control much smaller. I will make the control 1000. Now, can you see that the significance of it changes? I'll make the change. So what was the significance? 50,000, right? The significance was 5.3 E minus 0.6. Now, if I make it 1000, you will see it is changing. It is becoming lesser. If I make it just 100, it doesn't change because the test is too large here. So let me make the test 10,000. Maybe test about 500, and the control is about 10. Then you get into a little bit of a problem. So if you see, it is changing. So it has to be statistically significant. That's what is important. It doesn't have to be equal. It has to be statistically significant, and by design, test is always going to be much larger than control.
Okay, thank you for your input.
Any other questions?
So there aren't any other questions for now.
Okay, great. So what I'll do is I'll go back to the presentation. Just give me a minute to share my, just a minute. Okay, hope you are able to share my, see my screen.
Oh, yes, it is visible.
Okay, good. Now,
thank you.
Now there are some cases. So we have looked at a comparison of means and some of the industry examples of how do we look at comparison of means. Next, what we will look at is testing about a distribution. Now look at the diagram on the right hand side of this slide. Now, if you see the green distribution and the blue distribution, they are definitely different. But their shape is same. They have the same shape. Now, in many cases, you do not want to test mean of the blue is equal to the mean of the green. That you test and see that the mean of the blue is higher than the mean of the green. Great. But the next question you want to ask is the distribution or the shape of the blue same as the shape of the green? Okay. Now, how do we answer that question? So there are a couple of tests that we have for this purpose. The most famous of this test is the KS test or the Kolmogorov-Smirnov test. There are a few others as well, but the KS is the most common test for comparing distributions. For other cases where you have more of 1-0 type of cases, you use other measures like the cosine similarity, the chi-square test, etc. But the KS is the most common test for testing distribution. We will just look at a quick example of the KS test and about the chi-square test. The other question is, what do you do about qualitative data? Say, for example, if you do not have, let's go back to the example that we were talking about. Let's forget that we are talking about salaries of students who have completed digital marketing versus analytics. Let's say we want to talk about if students completing digital marketing get get senior management role, more senior management role compared to students completing analytics. So it's a qualitative data, senior management or not senior management. How do we look at those cases? So we'll take a few examples of that. I will go to a few other real life examples when we need to look at similarity. The most common real life example when we want to look at similarity is something that you see every day in e-commerce. So that is called recommender systems. So all of you must have seen recommender system in some shape or form. Say when you go to an Amazon or a Flipkart to buy something, you see recommendations like people who have purchased this also purchased this, people like you have purchased this. So these recommendations popping up. Now, how do you get recommendations out of it? So as you know, all recommender systems came out of movie ratings, and they came out of the Netflix applications. Now the question is, let's think about these three individuals and these three genres of movies. They give different ratings to different genres of movies. Now I have to identify today if for say another person, I do not know their ratings, can I predict their ratings based on similarity? Now, if you see this particular example, say Sridhar and Shanti, now both of them have the same pattern of ratings, though their absolute values are very different. Both of them like science fiction the most, followed by horror and romantic movies. Now, I'm trying to get a similarity. I know they're different. I know Sridhar likes movies more than Shanti, but their pattern is same. So how do you look at pattern? Another example. This is called multidimensional scaling, and it is used a lot in comparing brands. Let's talk about 4 brands of cars that you may have: Suzuki, Hyundai, Nissan, and Toyota. And if you go to, say, social media, on blogs, people talk about positive things about these cars, people talk about negative things about these cars. So the green here are cases where people are talking positive about that aspect of the car, and then in the reds are the things that people are talking negatively about that aspect of the car. Now say you have gone to a website like Team BHP and you have got all their data about blogs that people have written about these cars, and for Suzuki you see that 750 comments have a positive about price. They say that Suzuki price is low, it's a good price, it's a good bargain. Whereas 276 people talk negative about space for a Suzuki car. They say that it's too cramped, etc. Similarly for Nissan, 112 people say that the car looks great, and 112 people say that the car's mileage is bad. Now, how do you, now if you are a researcher and if you want to find out, does Suzuki look closest to Nissan or does Suzuki look closest to Toyota or Hyundai? How do you answer that question? Okay, so we will just take this example. This is not very different from the earlier example that we talked about. We talked about movie rating. We'll take this example and we will see how we can create similarity using something called a cosine similarity, which is a very widely used similarity measure for comparing these distributions. Now, as you can see, this is a case where you have 1, 0. You may say good things about price or you may not say good things about price. Okay, so I'll just go to that example, that Excel sheet. Okay. Okay, so I worked out some examples here. Just okay. Now let's see. So the same information that was there on the power. Saif, are you able to see my Excel sheet now?
Yes, it is visible. We can see it.
Okay, so the same example, I have just now populated the numbers on the Excel sheet for what people are saying positive about these brands of car. So now if you see Suzuki, the 750 people are saying positive things about the price. Hyundai, 126 people are saying positive about the car, etc. Now, if you want to know, does Suzuki look more like Hyundai or does it look more like Nissan or does it look more like Toyota? So we create this measure called cosine similarity. And this is how we calculate cosine. So which is, as if you have an engineering degree or if you have studied any vector algebra, you know how is cosine calculated. It's AB cos theta. So A dot B divided by the mod of A and the mod of B. It's exactly the same thing. So what you are doing is you multiply the 750 into 126, 0 into 132, 200 into 0, and so on. And then you divide it by the square root of all of this, 750 square plus 0 square plus 200 square, etc. and the square. So this is the similarity between Suzuki and Hyundai. Now let us find the similarity between Suzuki and Nissan. I'll pretty much copy the same formula. Suzuki, I'll just change the cells here. Okay, now what's happening? So there is a little bit of a problem because there is 0 everywhere. So I'll change the numbers a little bit. These are fabricated numbers. So I'll just change the numbers a bit. Now this is the similarity between Suzuki and Nissan. As you can see, Suzuki looks closer to Nissan rather than to Hyundai. This is just a fabricated example, but this is the application of similarity. Now here you don't want to know, does more people say positive things on price about Suzuki compared to Hyundai? For that, you would have done a test of proportion or a hypothesis testing. Here, you want to know, is the distribution of what people are saying about Suzuki same as the distribution of what people are talking about Hyundai? That is where we use the concept of a similarity. Okay. So is that so now if you see the number of people saying positive things about Nissan and Suzuki and price is very different, but it is the similarity overall about the entire distribution that you are trying to look at. This finds a lot of use in recommender systems, which are used very commonly these days in your e-commerce and similar applications. Okay. Any questions on this?
Hindul, no questions as of now.
Okay, great. So, Saif, I'll just take a 1 minute break and I'll just be back in a minute. Okay. Just sorry, everyone. Just give me a moment.
Okay, sure.
Okay. Hi, everyone. Welcome back. So we will see another quick example, which is an example of a case test that we perform. And this is something which you will encounter very commonly when you test your models, when you go into logistic regression or even any other discrete choice models or even neural the case statistic quite frequently. So the calculation of the case test is very similar to that. Okay, so I'll take an example of a case test. Okay, now let's say let me take the same example of about who have course 1 and course 2 from a particular university. Okay, and this is the range of salary. Say this is 10 to 20, 10 to 15. Oh. 10 to 12, 12 to 15, 12 to 14, 16, 16 to 18, 18 to 20, 20 plus. Okay. Now you have, say, in course 1, 20% students, say 12% students here, 8% students here, 30% students here, 12%, say 7% students here, 12% students here. What's the total? 5 and maybe 25% students here. Okay. Now, if you look at course 2, you may have 10% student here, 12% student here, 22% student here, 18% student here, 20% student here. So what's the total? 2. So there's 18% students here. Okay, so this is the distribution. Now, you want to know if the distribution of salaries, I'm not interested in the average salary. I'm interested in if the distribution of the salaries are similar. So you can just plot it as a simple bar graph to first see what it looks like. You can see this simple bar graph. Now the question is the distribution similar or not? We do not know. Okay. So how to look at something test or Kolmogorov graphs? So we create something called a cumulative distribution. So all of you, so this distribution is nothing but what you called is a probability density function, or a PDF. And a cumulative distribution is nothing but what is called a CDF, that you may have read in your basic statistics course. So what is your CDF? So first it is 12%. For the next group it is 12 plus 8%. So it is dollar here, and then drag it. It goes up to 100%, correct? Similarly, for cumulative distribution for this is course 1, and then I'll have a cumulative distribution for course 2. Okay, both of them adds up to the 100%. So K stat is the cumulative distribution of one minus the cumulative distribution of the other. So if you see, your K stat goes to about 6%. Now, as this is a non-parametric test, there isn't a significance or something like that. So what this is, usually a K statistics of more than 20% tells us that the distributions are different. A K statistics of less than 20%. So case, if you look at the maximum would have been 20%, then we would have said the distribution is different. Let's just try that. Let's just say that here we have 30% of people here, and so this total be, so we take out 0% here. Now you see the K stat has become 24%. Now look at the graphs. The distribution does. So that's how is a K statistic used, or a case test is used for comparing distribution. Okay. Now the next thing that we will study is chi-square test, contingency table, and chi-square test. Okay. Let's again take another example. Let's say again we will take the course 1 and course 2 example. Percentage of students in senior management, percentage of students in middle courses. Fine. So say this is an so percentage of students in junior management, just to make it a little interesting. 20%, 60%, and 20% for this course. For course 2, it is 30%, 20%, and 50%. Okay. Now, if you look at, so we create something called a contingency table. So, in course 1 and course 2, how many people are there? Out of say course 1, say there are a total of 1,000 candidates, here total of 1,200 candidates. Okay. Now, how many exact candidates do you have here? This into this. So now what we do is, so this is from course 1, this is in course 2. So we create a chi-square test to test if this number of 200 and 360 are same or not. So we use something called a chi-square test. So you find out what is the, so now if there are, sorry, so let's make the number of students same here, so that if it would have been same students, what would have been the distribution? You want to know if they are similar or not. So you have this chi-square test, chi-test, chi-test. You have actuals, and this is the expected range, and you want to find out if they're equal or not. So it says that the chi-test is 0. That means that, so the value is almost 0. So that means they are equal. So the distribution are more or less equal. Okay. So that's a chi-test. A chi-test is also used in many cases in figuring out the efficacy of our models, like a Kolmogorov-Smirnov test, where I want to know if the actual and predicted are same across various ranges. Okay. So with that, I will go back to my presentation, and I will go through the rest of the presentation. Okay. Now, then we will go into something which we call is a power of a test, or the alpha and the beta errors. So when we perform a null hypothesis, then we make certain about the true nature of a particular phenomena. For example, what I say is, based on the data, I infer that the test is higher than control. But in reality, test may or may not be higher than control. So in cases where I do not reject the null hypothesis, so I say test is equal to control, and I do not reject this. And in reality also test is equal to control. I make a correct decision. And so if I reject the null hypothesis, and in reality also test is different from control, then I do not make an error. I make a correct decision. In the other two cases, I make an incorrect decision. So these two incorrect decisions, the alpha is called the type 1 error and the beta is called the type 2 error. Okay. Now, one interesting theorem or one interesting phenomena that you may not have studied in your theoretical class is a theorem called the Bonforni theorem. So what the Bonforni theorem states is, say you want to perform hypothesis testing over time, repeated hypothesis testing every month, then your chances of making a mistake goes up. Therefore, you need to be more conservative in selecting your alpha and beta. For example, if you are performing the same hypothesis testing every month, so for 12 months, and in each test you want a alpha level to be 0.05, then in order to be conservative, what Bonforni theorem states is you divide alpha by 12 or alpha by whichever number of times you're performing the test, and use a more conservative alpha. Okay, that's what is the alpha and the beta. But that's theory. Now let's connect it to what happens in real life. Now the question is, how do you determine alpha and beta? Now alpha and beta is dependent on the cost. Now, whenever we make an error in decisions, there is a cost associated with it. So with both the type 1 and the type 2 error, there is a cost associated with it. Now, based on the cost, we need to select what should be the level of significance at which we need to test a particular hypothesis. Now, let's take this example. Now, let's say you have access to the data of a gym, like say Gold's Gym,
about what is the membership fee that every member pays there. And what you assume is that anyone who pays more than 5,000 membership fee must have an income of more than 25 lakhs. And therefore you think that they are customers who have high income, and you send them a free copy of a particular magazine, say a magazine like anything like say India Today. You send them a free copy of it, and along with an offer for say you are a hotel and you have a luxury spa, you send an offer for your luxury spa along with the free magazine. Now think of it. In some cases, so what is the inherent hypothesis you are testing? You are testing the hypothesis that if your gym spend is more than 5,000, then your income is more than 25 lakhs. So that is your hypothesis. Okay. Now, if that is your hypothesis, and if your hypothesis is true, then you are doing the right thing. You are giving a freebie as a free India Today or maybe a more costlier magazine like National Geographic, and you don't mind because you are reaching the right people. Now, what if you have a few young health enthusiasts? They're college students, but they are very enthusiastic about health and fitness and about bodybuilding, and they spend a lot in their gym. Now, that is an error. Their spend is more than 5,000, but their income is not 25 lakhs. So you waste your offer money in sending them a glossy National Geographic. So that is what is your offer cost. And based on this cost, you have to find out at what level you want to test a hypothesis. Take another example. And this is again an example from the telematics world. Today, if you see every car, particularly if it is a little bit of a costly car, it has this telematics built into it. What telematics mean is from the car engine, there is a central server which keeps on getting data from every component about the car engine or every component in the car. The central server gets data through sensors about every minute, and that data can be analyzed. And you have data on everything. So you can have data about the temperature, the RPM, etc., etc. Every data that you can have about a car that is stored in the central server through a sensor pretty much every minute. And you can build a lot of complex models to identify if a particular component within the car is about to fail. Let's say you still haven't done that, and you are only monitoring each one of these signs or each one of the signals coming from the car. And one of the signal is the exhaust temperature. Now, if you know that the exhaust, so say you have a hypothesis that if the exhaust temperature is more than 200 degrees, then there is a problem in the engine. Okay. And what you do is you send an SMS to the owner of the car and ask him to get the car to a service center where you will open the car and check and get the defect fixed. Now, if you have an error in your hypothesis testing, so if the temperature is over 200 degrees centigrade, there is nothing wrong with the car engine, then what is the cost? The customer brings in the car in the service center, you spend some effort in opening up the car and checking the car, and the customer also gets irritated because he had to rush to the service center. So there is a cost. Now, if it is the other error, you say it is 200 degrees centigrade, but the car is fine. But in reality, the car has broken down. Then what will happen is in the middle of the road, the car breaks down. The customer is also irritated. You have to tow the car to the service station, fix it, and give it back to the customer. Now, all of this is costs. Now, the relative level at which you should check a hypothesis depends on these two costs, because both the type 1 and type 2 error have a cost associated with it. And you have to understand the cost to find out at what level of significance you should test a hypothesis. Okay? So I'll take a quick pause here before we go to design of experiment and ask you if you have any questions.
No questions as of now.
Okay, good. So in that case, we will go to this design of experiment. So what is design of experiments? Now, in many cases, you will find that business managers will ask you, do our customers love freebies? Do our customers love discount more than a free gift? Do they love a coupon compared to a freebie, etc.? Now, you as a analytics person, you have to answer these questions to the business manager. Now, how do you know the answer to these questions? The best way to know the answer to these questions is ask the customer. Now, how do you ask the customer? You have to ask the customer. You have to conduct tests. For example, if you have, say, a product, say you have a product like microwave, and you have two offers. One is you give a 5% discount. Other is you give a bowl free with the microwave. What the customer like more? How do you know? You test both. One case you give a 5% discount, and in the other case you give a free bowl. See where more customers are taking up the product. So that is what is called experiments. By the way, many of you may know that I have a book on analytics. It's called Business Analytics Applications to Consumer Marketing. There is a detailed section that I have on design of experiment. I encourage you to look at that section because today I may not get a lot of time to take you through design of experiment in detail. But if you read the book, we have listed out design of experiment and how to conduct design of experiments. Okay. So what we have to do is we have to conduct a design of experiment framework to answer this type of question. So today I will take a case study. And the case study is, say you have a banner ad. All of you must have seen banner ad on websites. Like, what is a banner ad? So say you go to ndtv.com, you will see on the website ads for cars, life insurance, etc. Now, if you have a banner ad, there are a few variables about the banner ad that you can test. And the good thing about online is you can test pretty much anything. So say, what does a banner ad contain? A banner ad usually contains a picture of the product, or sometimes a picture of a celebrity, something like that. A text message, a text about the product, the best life insurance, having this, a message about the product and the offer. And it also contains the link. If you click on that link, you will go to that particular website. Say you say that best life insurance from ICICI Pru, and then there is a link that takes you to ICICI Pru websites. Now, if you look at a banner ad, what are the variables about a banner ad? First is a position. So if you think of a website, you can either put the banner ad in the right or the left of the website. That's a position. Now, in the banner ad, there is a call to action. What is a call to action? It's a link that said click here. Now that can be either in the top or on the bottom. As you can see in the diagram, it can be either in the top or the bottom. Then sometimes you will see that there is an animation. You will see there is some small animation going on in the ad. So you can have the animation, you cannot have the animation. Some people say animation is good because it catches the attention. Some people say animation is not good because it sort of irritates the customer with too many things moving on the page. So, but you don't know. How do you know? You have to ask the customer. Now, position of the banner ad. It can be either left or right. And then you can have a picture within the banner ad. Say you see the picture of a happy family in an insurance ad. The picture can be in the left or the right of the ad. So these are all the combinations that you can test. So if you see, ideally there are 24 combinations that you can test, because there are three cases where you can have the position of the picture, left, right, middle, which is 3. Position of the call to action or the link, which is 2. Presence of animation, this is 2 because presence or absence. Position of the banner on the website, left and right, again 2. So there are 24 combinations that needs to be tested. A lot of testing. So, however, the problem is that if you have to test, you have to find out what is the objective. Now, usually for banner ads, the success metric or the objective of the ad is click-through or a click-through rate. What that means is, if you show that banner ad to 1,000 people, how many people finally clicks to the link and goes to the particular website? In this case, how many people clicks and go to the ICICI Prudential website? That is your click-through rate. That is the success. Now, if you look at the equation at the bottom of the page, So what I'm saying is the equation is essentially, say, you assume that you can model it as a logistic function, and the click-through rate is a function of the position of the picture. So this is beta1 into position of picture, left to right, and etc. Position of call to action, all of those. Okay. So if you look at it, all the combinations, you can have all these different combinations possible. Okay. So if you look at the number of combination, you will have C1 to C24, 24 combinations. Let's go through one combination, say, which is C4, where the picture is positioned on the left side of the ad. The link or the call to action is positioned on the top. It doesn't have an animation, and the ad is placed on the right side of the website. In this case, the equation for your response is your alpha plus beta1 plus beta3. So because of this, if you have 3 levels of a particular factor, we usually create 2 particular dummy variables. So here for beta1, there is towards the left, and beta3, which is your presence of animation, it is 1. So you can see all the combinations that is possible. Okay. Now the question is, do we have to conduct all these 24 experiments, or can we limit the number of experiments in certain way? Now, what design of experiment does is it helps us limit the number of experiments, and that is what is called as a partial factorial design. Now, if you have to experiment all 24 cases, that is what is called a full factorial design. But if you can somehow limit the number of cases that you have to experiment, it is called a partial factorial design. We'll go to what is a partial factorial design. Now, this is a slightly loaded slide. Okay. Now, if you look at the combinations which are highlighted in gray, if I test those combinations, so if I test, say, C4, okay, or rather, say, let's start with C24. If I look at C24, if I test C24, I know the value of alpha. Now, armed with the value of alpha, if I test C4 and C8, I can calculate beta3, because if I subtract C4 and C8, what will be left is beta3, because alpha and beta1 gets cancelled out. So if I conduct experiment C24, C4, and C8, I have alpha and beta3. Now with this, if I go to experiment number C12, I already know alpha, I know beta3. So if I know the results of C12, I can know beta2. Similarly, I can conduct only these shaded number of experiments, which are just 7 experiments, and I can get all the betas, and therefore I can know the result of any other combination that business may want me to answer. That's the power of a partial factorial design. Okay. I know there isn't enough time to explain design of experiment in detail, so I really urge you to go through my book. If it is not possible, there is a paper that I wrote on on the same example sometime back in one of the blogs. I will share the link. It's called Analytics Vidya. There's a blog there on the same topic that I wrote sometime back. You can go through that blog as well to study design of experiment in detail. Now, the next thing that you see is something called interaction effect. Now, what you may say is, here we are saying that we are looking at the impact of each one of these factors separately. Now, what if there is an interaction or a combination of the two? Now, say there is a placement on the website is left and presence of an animation. If you do both of that together, you get a slight bit of an incremental impact on click-through rate. That is what is called interaction. That means what essentially interaction effect means is 1 plus 1 is more than 2. So presence on the banner ad on the left adds value, presence of an animation adds value, but if you do both of them together, you can get more value than each one of these done individually. That is what is called called interaction effect. Now, if you have interaction effects, then if we just test a partial factorial design, it is not enough to get all information. Then you have to test more combination. And if you believe that there is interaction between all the factors and all interactions are important, then you can't really limit the number of combinations that you have to test. You have to test something called a full factorial design. So that was a quick on design of experiment. I'll just take a pause here and like to know if you have any questions. And I will also give you this link to the detailed design of experiment blog to go through. You can also go through my book, and that will give you the same examples in lot more details that you can read through, because it's difficult to cover design of experiment so quickly. Okay, any questions that you may have?
Just give me a minute. I'm waiting for questions, so you can then continue. Okay, so there's a question.
Yeah,
so it says DOE for testing hypothesis is one part and developing response surface is another. So when to use what?
Okay. Thank you for the question. That's a very good question. So if you see DOE for understanding what or performing hypothesis testing, there what you are doing is you are trying to find out impact of each factor separately, right? When you try to build a response surface, you are trying to find out impact of all the factors taken together. Now, in the end goal for all design of experiments is finally to create sort of a response surface, similar to what we have done here. But to do that, to start off with, you have to perform hypothesis testing for each factor separately, and then combine all of them. So if I may say that DOE for hypothesis testing is a step 1. And once you combine all the hypothesis testing into a response surface, that is the step 2 or the final step. But you have to go from step 1 to final step, because testing always has a constraint. You can't test everything in one go that you may want. Though as analysts, we may want to do that. Therefore, you may not get all the data to create that response surface in one go. Therefore, you may have to limit yourself with testing hypothesis of each factor, of a few factors, and then as you develop more experimental results, you get into a position where you create this response surface. Okay, any other questions?
Thanks for the answer. So it looks like there aren't any more questions coming in. So I'll just wait for about half a minute to see if there's any other question, and then we can finish this session.
So okay, so that's good. If you, I may just point you out to the blog on design of experiments.
Sure, you could share the link so I can.
So I will just. Okay. Share. Are you able to see the screen where I have this beginner's guide to design of experiment?
Oh no, I can't see the screen.
Okay, so if I see share desktop. Let's see. Open it as a. Open link in new window. Now it will come up. So I go here. So are you able to see my screen now?
Oh yes.
So for everyone, so this is a blog from which I took this. Is a blog that I wrote some time back. So here you have the full design of experiment case study that I was talking about, and I would request you to go through it so that the same thing that I spoke about, it's listed in a lot more details. Okay, any other questions?
Oh yes, there's one more.
Yeah.
So one last thing is how to attach cost of error to the DOE output.
Okay. Okay. So if you have an error, so let's say what is an, so for every hypothesis, you can calculate an alpha and a beta, correct? So say you have tested an hypothesis at 95% confidence, right? So there are 5% cases where you will go wrong. Okay. Now, if you are going wrong in a 5% of cases and you know what is the cost of each error. Now, say let's take that example of a person of a car exhaust temperature going more than 200 degrees centigrade, and you say that that means the engine, there is something wrong in the engine. Now, in 5% of times you make an error. Now, if you see, if you take the engine, if the person takes the engine to the service center, there is a manpower cost in opening up the engine, etc. Let's say that is 5,000 rupees. Okay. And say if you find out that there is nothing wrong with the car, the customer gets irritated, you have to give him something. You give him a small freebie or something. So that costs another 2,000 rupees. So the cost of this error is 5,000 rupees. And 5% of times you end up making this error. You have 1 lakh car out there on the road. So 1 lakh into 5% into 7,000 is the cost. Now, how much is the cost? So you calculate the cost. And can you afford that cost? Maybe you can't afford the cost. Then you test it at 99%. Then your cost becomes 1% into 1 lakh into 5 into 7,000. But on the other hand, there is other cost. The cost of the type 2 error now goes up. Now there is a car which breaks down in the middle of the road and you have to tow the car to a service center. And the towing cost of another 1,000 gets added to it. So there's an 8,000 cost. So 8,000 multiplied by beta into 1 lakh is the cost, is your type 2 error cost. Now, based on these two costs, you have to sort of optimize your total cost of your errors. Usually, in most cases, one of the costs overshadows the other, and therefore the decision is easy. But in some cases, the costs are almost equal, and therefore making the decision becomes difficult. Hope that answers your question.
Okay, so I think we can proceed with wrapping this off and closing this session. Thanks for all the demonstrations that you've done. So we will be needing the Excel files and the presentation for the students. So thanks for devoting your time. I'll just.
Thank you. Thanks, everyone. Thanks, everyone, for your time. I will mail you the presentation today, the Excel files,
Yeah, sure.
a little bit, and mail it to you in a couple of days' time.
Sure, that sounds fine.
Okay. Thank you.
Yeah.
Thanks, everyone. Thank you.
Okay, so everyone, the PPTs and the Excel files will be shared shortly once we receive it. And as for the video, it will be uploaded by tomorrow on the platform. So you can access it anytime on the same link that you are watching it right now. So in case anybody asks for it, you can share this link, YouTube link with them. Apart from that, I think the link of the blog has been shared on the chat of Analytics with you. So this is pretty much the session that was intended for you. And thanks for being a part of it. And enjoy the weekend. Bye.
Bye.